So everybody should have in their journals a number which you're going to keep very handy. It describes how many meters you cover per pace. Okay, so to get from paces of the hallways to actual meters in the hallway, we just multiplied by that number. For most of you, it was somewhere between 0.6 meters per pace and like 0.8 meters per pace. Somewhere in that neighborhood. Okay, so today, first thing, we need to now convert meters to centimeters. What we are not doing is converting in real life the length of the hallway in meters to, in real life, the length of the hallways in centimeters. We're not interested in that. This is not move the decimal place over. What we're interested in is, in real life, meters, hallway lengths, how are we going to represent those real life lengths on our map in centimeters? So we have to develop some kind of a scale, okay? And you get to decide this. Now today, I've given you a blank piece of 8.5 by 11 paper. So, whatever our scale is got to fit onto this piece of paper. You get to decide, right? So, you may decide that, you're going to use 1 centimeter to equal 10 meters in real life. If you do that, what is your map going to look like? What are the lengths going to look like? So right now, everybody, take a minute and look at the longest length, the longest hallway that you recorded yesterday. Everybody look at that right now. What is it? About? 26 meters. Anybody have anything longer than 26 meters?
I got 45.
45 meters. Okay, so if your scale is 1 centimeter equals 10 meters, then the longest length that you have is going to be about 4.5 centimeters. Right? If you divide those. So think about this for a second. Take a look at your ruler. Okay? Take a look at your ruler. Take a look at 4.5 centimeters. Is that the size that you want? Alright, take a step back here for a second. Let's do a quick calculation. We know we want to end up with centimeters. Let's just do our quick math problem here. We want to end up with centimeters, right? We know we're going to have a scale, which we're going to invent, where a number of centimeters is going to equal a number of meters. Right? So if we start out, my example of 42 meters, we want to cancel the meters. We want to end up with centimeters, so what's got to go on the bottom? Meters. Centimeters is going to have to go on the top. In this way, we will cancel the meters. We end up with the unit in centimeters. So, the mathematics of this, whatever you choose as your scale, if you choose 1 centimeter equals 10 meters, then the 10 is going to go on the bottom, the 1 goes on the top. Whatever this is, you will divide by your scale, 10 meters in this case. If you decide that 1 centimeter is going to equal 5 meters, you would divide everything by 5. So this is going to be an exercise in just real simple division. All right. So let's say hypothetically we use 1 centimeter equals 5 meters. Pick the longest length you have right now. Look at your data.
45.
What's the longest length? Divide that number by 5. It's going to equal some distance in centimeters. What is that distance? What's the longest one? What is it?
9.1.
So somewhere between 8 and 9. Does that seem reasonable? What do you think? That's 9 centimeters. That means the longest length is going to be that big. Does that seem reasonable for this size piece of paper? Okay. So if you say yes, then right now, everybody, take a minute, divide all of your data by 5.
You want to do 10? Or doing 5?
Divide all of your meter data, here's the meters, to get to centimeters, divide by the scale, in this case we're going to divide all those numbers by 5. Okay, do that everybody, and we will be right back. Okay, everybody, we're back. We now have our centimeter data. Okay, everybody's calculated the number of centimeters you're going to use to represent in real life a distance in the hallways. So, we are now at the point where we're ready to make a map. I'm going to draw a rectangle. This represents the piece of paper you have in front of you. When we do our maps outside, we'll use a piece of paper that's much bigger. We'll just adjust the scale. Okay, so how do we make a map then? First of all, we can put our handheld compasses away, and all we really need now is a little paper compass. Paper compass that has on it all 360 degrees of the compass rose. Okay? So we no longer need our handheld compass. The handheld compass, what this provided us was a frame of reference. This points, it has a needle that always points north. That north needle provided us a frame of reference by which we could locate every other bearing, right? So instead of using a handheld compass, we just employ a standard convention in mapping, and that is to define north as up. So usually when you make a map, north is up. So now that we have north defined as up, as long as we keep our paper compass always with north up, then every other compass heading that we map will have the correct orientation. Okay, so we have our data, we're ready to start our map. So with north up, what I'm going to do is I'm just going to pick a point. I pick a point that's fairly logical. I know I'm going to be going to the right 90 degrees. So my first point I'm going to pick right here. Always with the compass, north, same direction as the north that I've defined. That's our frame of reference. I put the center of my paper compass on the point I just made. And my first data point is 90 degrees. I put a dot at 90 degrees. So I know my first line is going to travel through that dot. I have to move 8.2 centimeters. So with my ruler, through the dot I just made in a direction of 90 degrees, I travel 8.2 centimeters. This line now represents the hallway directly outside my classroom. This is the starting point. We walk down toward Miss Mickelson's room. I'm going to label that because it gives me some frame of reference. So Mr. T's room is right there. The point where I left off. Center my compass on that point. North is still up. My second compass bearing is 195 degrees. Put a dot at 195 degrees. My next line is going to travel through that dot 11.2 centimeters. 11.2 centimeters through that dot. That's my second line. That's my second hallway. 25 degrees, 3.8. Center of the compass. North up. 25 degrees. I'm heading backwards. 3.8 centimeters. Every once in a while, I might put a mark down here like Miss Mix Lockers. So I have a frame of reference. I continue mapping until I get to the end.
You just go whatever way.
You don't go just any old way. You go the direction based on the compass heading that you collected. Use your data. Okay? And that's it. You should end at the exact point at which you started. Okay, so everybody, at this point, you are ready to make a map. Pick a point on your sheet of paper, center of your compass to that point, make sure north is up. One last thing. On your map, and for every map, you must always have the following things. Always give it a title. Always include the scale. In this case, 1 centimeter equals 5 meters. Always define what direction is north, and then add to it some frame of reference. Add some locators. Okay? Okay, we're going to make some maps. We'll be right back. Okay, let's take a look at one of the maps. Here we go. F-wing. Not bad. Got the little bank of lockers over here. Here's the square around the LMC. Back to my classroom.